So the topic is very clear. I will just focus on talking about whatever is our experience during last some days. So this is a brief of Maharashtra power system. I will not go into details of the numbers, but you can see there that even though right now the renewable is not very much, but still it is reaching around 25% of the installed capacities. And if you look into that, we have a 2.94 gigawatt of hydro, which we use as a flexible resource and which is a great help into the system. The demand has almost touched 30,000 megawatts. Other things are just numbers. So this is how RE has developed in Maharashtra in recent times. If you say earlier, solar was not much there. The development from April 20 to October 24, solar has picked up. It has reached 5,000 now. So both 5,000 wind and solar combination is right now. If you look at the geographical regions where from the solar and wind generators are coming. So this is the picture which I think earlier speaker Marutkar sir also was referring to. So which were saying, which is changing the nature of transfer of powers within the state. The STU has made the plans accordingly, but this changed nature of power is basically because of two things. One is the locations of these resources. They are not as earlier traditional resources. The locations of resources have changed, and the distributed nature of these resources across the state because of different schemes taken up within the state. So this is the time duration curve for the state plot. You can see that 80% of the period state demand was more than 20,000. I have put a graph of the demand ramps that we normally observed. The maximum demand ramp we observed in the year 23 was around 1200 megawatts, and it is the demand block behavior that is for the state. So two things I want to talk about this figure. What probably we have not included is we also looked into the demand growth in Maharashtra from maybe around 2010 or 15. So when we look at that, the demand rise is one part, but there is the gap between the daily maximum and daily minimum is also reducing over the years. That is telling me the requirement of firm power particularly is also changing, particularly in the evening hours and maybe late night hours, and the demand trends also indicate that the usage of cooling devices, usage of ACs will be a major issue in upcoming years. So this is the actual energy scenario. If you look, still my major contributions are coming from thermal. One more issue that states generally face will be whatever we are drawing from the interstate grids for the outside the state. We generally don't know how exactly the instantaneous contributions from the RE sources beyond the states are, because so that indirectly is also providing a flexibility mechanism to the intrastate networks. But if you look at the solar and wind contribution, it is around 7% in energy terms. So as we try to look into these data nowadays, we cannot just, as we all know, we cannot just look at the peak demand data only. So we have been looking at the 4 cardinal points for the day: a morning peak, day peak, an evening peak, and a night off peak. And these are 4 chosen data points of the day. And you will clearly see the differences in contributions of each kinds of sources during these cardinal points. And this is one of the, as we talk of variability, we talk of the nature of these resources, and we talk of their increasing installed capacity. So these, even going ahead, I say that looking at only these cardinal points won't be sufficient. And when we talk about the adequacies, we have to talk about probably each block adequacy, looking at these new kind of sources coming into the grid. So we did this study particularly for all the days of around 4 years, and one interesting observation from this was, if this is the state demand versus the net demand, that demand calculated by removing the wind and solar from the state demand. So if you look at these demand pictures and look at the monsoon picture, finally the difference between the day demand and net demand increases in the monsoon picture. Though I have just added to only this morning 8 picture, morning 9 picture for year 23, and then I have added a picture of 700. But we have looked into a lot of data, and we have always seen that at all time it is the monsoon season. So this brings a peculiar point as a dispatcher for me, because this is a season traditionally we are accustomed to give large outages during this period, considering that the demand is going down. So when my RE resources will be increasing and my firm resources will be depleting, the kind of outage management systems that we will be working with tomorrow, the traditional logics of outage management may and will require a change, because this will be a time where the variability within the RE sources will be increased. The firm resources will traditionally, if you look into the traditional way of using firm resources, will be under outages, and anything happening with the RE sources, the if I say ki, whatever available ramp limited reserves are there within the system at that time, it will have an impact. So this is variability, no need to prove, everyone is knowing about it, but this is the picture of variability. So this is the variable patterns of the wind within the states. 58% of the period in the year, the injection was below 900 megawatts with 5,000 megawatts of installed capacity. And it was only around 10% of the time, it was beyond 2100, annual CF coming to 19%, etc. And this is a picture of non-windy season and windy season in February and June 23. Look at the consecutive days and the behavior of these sources. It's completely changing. One day it's quite low, and suddenly just 2 days after that it comes up a lot. This is for wind on consecutive days in non-windy as well as in windy seasons. Solar, we have a feeling. Just at the time of lunch, we were talking with Shri SLDC Gujarat, and he was saying that we had a feeling that solar is better, but now we say it was only feeling. And it has its own issues. And so this is the picture of solar. Around 25% of the period of time, the injection was well below 500 megawatt, and CEF 22%. Maximum 94%, sometimes it goes quite high. And if you look at the daily maximum injections over the year, it has these kinds of patterns generated over here. This is again solar on consecutive days. So you will see a lot of changes intraday as well as across the days. So we have to look at the changes happening across the seasons, across the days. And so nowadays, how much micro and how much macro is both getting mixed, and you need to look at both the scenarios probably with simultaneity always there. So there was good enough variation as indicated in these graphs. And this is an interesting case that we came up on this 3rd December only, and we were at the control room, and within 30 minutes we saw a decline of around 500 megawatts, and probably the next 2 speakers will have many examples of this kind to tell from Gujarat and Rajasthan. But with the limited solar currently, so if you see how much was the generation at that time, it was 1990 megawatts, and it went down to 1470 megawatts within half an hour. It's more than 25% reduction. This is so this happened, and it has its impact on, but this was 500 only, so we could pull a lot of power from the grid. Our OD increased, we could pick up the hydro, and we could run the system for that much of time. So I tried to look at the geographies in which this was happening. So this is the geography of the locations where generation at that time reduced in that map, and where the location where it increased. So see, just a cloud cover at some of the plants where concentration of the plants is there, and it changes. So we try to scale it up. What will happen when, as planned, we go into 25,000 megawatt of solar, and how we will, and then we will shift the agri demand. We are talking in Maharashtra and I think many states of shifting agri demand. But when we talk of solarization into distribution system and shifting of agri demands, we have to remember that now the responsibility of flexibility also has to be connected with this demand, because the variable source is going into the distribution and we are shifting lot of demand. So, and with lesser arrangements of flexibility available in the system, this demand probably also needs to be flexible and some kind of arrangement. And this was one of the recommendations that we also gave and suggested a particular scheme in while implementing the Maharashtra's MSKVY 2.0 scheme. So this is what will happen. Solar eclipse observation in 2020 when the installation was not much, but we can clearly see the reduction of solar suddenly. But I want to point out one interesting observation over there. We saw that the demand also went down in eclipse. It was a small, it was 500 megawatt. Maybe next eclipse we'll wait for what happens next time. But I was thinking, why did demand go down in this? The solar going down is obvious, it's understandable. Probably in case of eclipses, it is predictable quite nicely. Why did the demand go down? So I always say, what is demand? Demand is people. Demand is people. People's behavior. People who are paying for energy is demand. So understanding people's behavior in different scenarios becomes also important when we are managing the grid with the kind of changes happening. If you look at the Nisarga cyclone on 2nd and 3rd June, this is the area of Nisarga and these are the plants, they were located in the Nisarga. And what we observed in the Nisarga was, if you look at the two graphs, wind on 1st June and 2nd June and the 3rd June graph, the 3rd June with fall of the cyclone, wind increased anything and then there was a demand fall, and in 3 steps the wind generation had to be curtailed to a lot more extent. So this was the extreme measure that had to be taken, because normally we are dispatching it as the must run sources, but in such cases we had to curtail the RE resource in 2020. What are the issues? See, the accuracy of forecast is one of the important issue, and that needs to be addressed in multiple directions. So when I was looking into this 500 megawatt fall I just talked about, and when we were analyzing that, we had a meeting with IMD even, and I asked them, and here is one area of work that I see as going to be important. If you look at the weather data available with these agencies, there are state agencies, there are central agencies, and there are developers who are putting up their own plants. And all this data is segregated at different places. When I was talking to IMD, and ultimately discussion mein ek point aisa aaya ki then they said ki, but for the state you will have to arrange the state's data, because then only. And second important point is, even though the REMC scheme design done some years back is serving some purpose, it's no more sufficient. It's no more sufficient. That is what I can clearly see. Because the prediction needs to have more and more localized flavor of these RE resources. It cannot be taking. It may be, technically it can be, but it may not be useful. So, when I was talking to IMD team last month, they were quite confident that this is workable if we can integrate really these kinds of data coming from different sources, and then a AI solution can be there for predicting these kinds of things. So predicting the generations, or I will say keep predicting at least the high intensity events, right? For which we have to be ready maybe within 2 days or within a day or within a short time needs to be there. That was what we feel. This is one of the important points that state dispatchers will always think about, the drawal from the interstate boundaries, because not just because of the finances, but all your frequency behavior is connected with this, and dispatchers have a role to maintain this. So if when we analyze the deviations at state periphery and the intrastate RE behavior, this is what, because this is the impact ultimately the states discoms will have to pay for, because there are two things. The accuracy of RE forecast within the state, if it is not correct, the discoms will have a tendency to contract powers, maybe in excess or maybe in lower. And both the things, it will have an impact on the state periphery deviations, ultimately affecting the frequency of the state. And I think last 1 week or 2 weeks, there is a lot of discussions about frequency behaviors and at different times at the national level as the RE goes on increasing. So frequency behavior will be one of the important points that we'll be looking at further. This is the Mukhyamantri Saur Kushi Yojana. Some details were shared earlier. I see this scheme as a very ambitious experiment of creating an active distribution system in the network. Because we are connecting solar directly on 11 kV. Directly on 11 kV, solarizing these feeders. So, and the volume is going to be more than 15,000 now. So, 15,000 gigawatt injection plus 10 to 15,000 plant other injections of solar. So, the state demand around 30,000 right now, whatever way it will increase, it will not go, even if I consider the demand of 35,000, the RE installed capacity of around near equal or 70-80% of this demand will be there in the state. And the demand falls in the monsoon. The demand falls in the monsoon. Monsoon will have typical behaviors, particularly when we solarize the agriculture feeders. So, like in monsoon, if there is good monsoon, the agri demand will also collapse. Any dry spell within the monsoon, the demand changes within a day. So these are the challenges that we will be having, and we need to have. So this was a study that we did for analyzing the impacts of the solar distribution solars. And one important point that is generally not talked about, I want to talk about is, now we all are talking about networks a lot, particularly transmission network a lot, and there as Marutkar sir was explaining, we have done some work for transmission planning in Maharashtra. But equally important, when we are doing so much of distributed planning plus so much of rooftop, equally important is looking into planning of distribution network. If we look in India right now, I don't think any of the distribution organization is having a distribution planning or network planning body. Part 1. There is no distribution planning guideline as such as of today. If I am correct, if I am missing something, maybe Sunil sir can correct me if I am missing something. And third point is, there has been no proper, we tried to do some analysis of the networks, the proper PSSC analysis of the distribution network for all the kinds of conductors used in the networks traditionally. It's a high time that somebody, maybe from academics also, looks into these studies, comes with some solutions and different designs. It's a high time that we also need, because we have already gone through 2 or 3 APDRP schemes without thinking of anything of changing basic designs of the distribution networks. So that, I think, is a very big area which will be important when we go for a lot of RE, rooftop, as well as the distribution connected. Impact assessment and actions required. This is a list is long, and I think everybody knows about is distribution control center. We suggested this, and DISCOM in Maharashtra is creating this one, because our study indicated that it has to have there. And our point was, it is not just the distribution control center, but we have to move into direction of the distribution system operator when we are planning so much of the distributed generation over there. A local level load generation balance, as I said, we need to have a demand flexibility. In case of agriculture feeder, the demand flexibility can be derived through a local level load generation balancing scheme. If there is an impact of distributed generation, it can be taken care of. A central ADMS, flexible operation, this is all fast response resources. The list is, the prescriptions are all ready. I'll say, everybody can talk of these prescriptions. क्या कहूँ, in Hindi, Dinkar ji is one of my favorite poets. और उनकी एक ये है कि ज्ञान की आराधना तो दिन का शयन है, क्लेश का निस्तार केवल कर्म से है. तो in IIT Bombay I should not say this, because ज्ञान कर्म जिनका है, यहाँ ऐसे लोग हैं. तो वो बात तो सही चलती रहेगी, लेकिन for a person like me who is just trying to pick up from all the great academicians sitting over here, the important part becomes what and how much and at what speed अभी हम लोग बात कर रहे थे कि दी डिस्पैचर्स हैज टू वर्क ऑन मल्टीपल फ्रंट साइमल्टेनियसली. द ट्रांजिशन इज हैपनिंग. ये बात कहना अभी बहुत मतलब द ट्रांजिशन इज हैपनिंग, बट एट व्हाट पेस? Solutions are there, but they are not running at equal pace. Even the understanding is also not coherently developing at multiple places. So resource ancillary services, I think grid code and everything defines all these things. So forecast accuracy, as I said, real-time data improvement, flexible operation. I will not go through this. You can go through my presentation for all these things. This is one of the points that I wanted to keep. The CES standard 2019 says the compliance, but look at the problem statement. As on date, there are 4,659 WTGs having installed capacity of 0.23 and 3.65 megawatt each, right? These WTGs are owned by around 918 individual generating companies, right? Out of this capacity, only 817 number of WTGs are type 3, which are compliant to the regulation. All the remaining 3,842 number of WTGs are of type 1 or type 2, which are not compliant to the regulation. Now, there is a chance that the new PSS is a combination of all these things. How to implement the standards, how to have solutions for this, how to have the whatever inverters are there. And I think somebody was raising a pertinent question when I just entered this room at the end of last session about the inverters and their testing. So thank you very much.
Distinguished speakers and participants, I think this is a cumbersome session actually, after having a good lunch then, but I will not take more time. I will conclude my session within 10 to 15 minutes because all of my previous sessions are already covered, national, international, and even state. My adjoining state is Maharashtra. So nature of the RE is almost the same. So it will just have a glimpse. I will divide the session into 4 parts. About Gujarat power session, then technical and operational challenges, then set experience so far, and way adopted to optimize the integration of solar and way forward. So the target which was given by the from the national, we have already touched this target. We are having a 45% of RE installed capacity from wind and solar only. If we add nuclear and hydro and rooftop solar, we have a rooftop solar in the country, highest number is 4.6 gigawatt. So we will almost at around 60% of renewable and 40% of conventional. In terms of the energy, we have a contribution of 16% in terms of energy from RECL. This is the last 10 years progress, you can say. Except 1920 and 2021 COVID period, there is a clear cut, you will find that the increase in the energy consumption as well as maximum demand. There is a difference between the 23 and 24. There is a high jump of around 3,000 megawatt peak because we have started to shift the agriculture demand into daytime. Because we find that we have to match our solar, our requirement of integration of solar have a huge target. So we have anticipated in 2021, 2022 that agriculture demand, which is in 8 hours in rotational shift, should be moved toward the daytime, and it will facilitate the agriculture to have a farmer. They have a lot of issues during night time. So we have started that activity in KIS 21-22 and onward. That is why maximum demand is moving fast ahead than the actual energy consumption in a particular top side. Then after wind generation, wind you will see that there is a cyclic up to 23-24. Not much addition in the particular wind generations, but in case of the actual generation, you will find that there is a cycle. This is a natural cycle. You will say every 5 to 6 years, there is a drop and increase. This is a phenomenon I have seen last 10 to 15 years cycle of the generation. Even though installation is same, but generation capacity or generation will be reduced and then up, reduced and then up. This is a cyclic phenomena in a particular wind generation. Initially in 2007, our solar was only 816 megawatt, which is touched at present. In yesterday only, our maximum generation from solar was 6,200 plus, and in terms of million unit, it was 42 million unit. So we have touched maximum energy catered during the last current financial 24-25 was on June 7th. It was 25.5 gigawatt, and maximum in terms of energy, it was 514 million units. So we are little behind the Maharashtra. Maharashtra is our leader in this particular as far as demand catered is concerned. And maximum wind generation as on date was 5,500, which was on 20th of June. And 120 million unit is the ever-time high energy generation from the wind generations. We have heard since morning variable. These are nature's intermittence, uncertainty, reactive power. This is the highest challenge we are facing at present. DSM violation. So we are a bit commercial. That is why we are mentioned here DSM, because it is beyond our control. We hit the periphery, regional periphery. Even we are generating more when not required, and we are penalized at the time of frequency was 50.10, and we have to pay the amount. So commercially also hit it. Then generally, not at present, because we have at present the option of distributed generations. So remotely, erstwhile maximum generation capacity as far as wind generation is concerned is located near seashore. So it's a location where demand is not required, power supply is not required, but generation is there. So it is remotely located. Then forecasting. Forecasting is till today we are struggling to have a better forecast. Then overruled merit orders, which is a commission's directive to follow the merit order, but we cannot always maintain the merit order. We have to sometime overrule the merit order, looking to the RE potential and RE generations. Then balancing mechanism, because we do not have any flexible generation like Maharashtra have, God bless with them having a pump storage and hydro, but we do not have such facilities. So we are struggling to balancing the RE variabilities. Impacting the conventional plants. Just before my session, I think our generating company has also mentioned that they have to bear all these up and down of wind and solar, because we are starting up and down daily 2-shift operation of the gas-based power plant, and in case of thermal plant, generally have an up and downs by virtue of the pick up and back down. So they are hitting a lot, in particular conventional plant. And at present, up till now, in the Gujarat, there is no provision of compensation for the up and downs and packing down, or even for startup and stop, which is available in the IGC. But at present, in recently MYT Regulation Commission has given a provision that you can claim case-to-case basis, and we will look into. So now provision is there, now onward. Then network inadequacy. At present, by adopting distributed solar integration, this can be avoided. And biggest one is must run. We can't touch him. So this is the maximum challenge we are facing, because we have to prove, as per the APTEL order, you cannot curtail the generation. Prior to all these, your conventional generation should be at a minimum level, and frequency should be more than 50 years. And voltage is up of certain level. So these are the benchmark given and decided by the APTEL, and based on that, we have to ensure first that each and every conventional generation should be at the minimum level. So these are the points. Now this is the real experience. Just Jawalikar Sahab has given. This is solar generation variabilities. You will find from 3,000 to 1,100. Most difficult issue is solar intermittency. You will find that 2,700 megawatt generation will be within the minute time, it will be 2,500, which is beyond control. Then at that point of time, generation is not needed, or generation is needed, but we will change our position as far as DSM is concerned. And last one is wind. So at present, we are feeling that wind is better than solar. Why? Because there is a certain time. There is a time of at least 1 hour, 2 or 3 hours time to reach from 4,000 to 100 megawatt. But solar will not take so much time. So these are actual cases of the Gujarat at present we are facing. This is a consecutive 2 days. On a 20th May, 80 million units wind generation was there. On 29th, it was 30. So, as per our planning, we have scheduled on D-1, we have tied up our all the power plant, procured from the power exchange or given the schedule to our conventional generator. On very next day, generation will be out. So, we are in trouble. Similar, next day is 6th June. Energy was in 33 billion units, and over next day, it is 74 million units. So, to handle the within a next day scenario, it is very difficult. And we are regularly received the notices and warnings, line openings from our regional load business center. So we become a villain in particular that part on particular days. This is another scenario in a consecutive days of solar. You will see on 25th November, 3,600. Very next day it is 1,500. On very next day it is 3,000, and again very next day it is 5,000. So 2,000 megawatt, more than 2,000 megawatt generation a very consecutive day, up and down. So these two scenario is also very difficult for us. This is the recent latest scenario on which we have received a lot of notices, particularly in that days. On a 26, we have planned our solar generation system designed as per the 25th day. There was on particular that day generation of from solar was 4,500 megawatt, and previous day it was 6,000 megawatt, and very next day, considering crowd, generation will be anticipated to 60%, and we have assumed that generation will be around 4,500. On very next day, it was 3,500. In the morning, you will see RTM power in power exchange was not available. So we have overdrawn 1,600, and frequency was 49.7. And that scenario continuously, you will find it was around 3 to 4 hours. So this is a very, very pity condition of us. Because in that particular day, power was not available, gas generation cannot be come up within a 1 hour notice, all the thermal generation on reserve shutdown. I do have a reserve shutdown of around 3,000 megawatt, but that was off bar. So this kind of scenario will be in future increase the such kind of repetitions. But this is the real challenge is particular solar is given. In case of wind, such kind of situation will never happen. So that is why we feel that solar is worse than the wind scenarios. This is the complexity of our at present system operation of SLDC. Total scheduling accounting is 855 numbers, our pool members. Out of that, solar pooling station on 11 kV side was we have discussing at present is 4,477. So maximum generation is connected at distributed level, which is also give the result that our losses is almost reduced more than 0.7% of transmission losses. That is contributed a lot at present particularly. And there is a variation in demand in megawatt particularly. More than 4,500 in a particular 2021 was almost 33 times, which is at present 126 times. So almost 1/3 time of the year, our maximum demand is vary between 4,500 any range. In case of the wind generation variation, you will find more than 3,000 megawatt variation observed in 2021, which is at present around 20 times. So this is the ups and downs of demand. Demand variation particular gap will be increased because we are converting the daytime power of the agriculture. That is why peak demand will be increased and minimum demand will be further put down. Transmission challenge in particular, the renewable section, due to remote location, infrastructure is required, then long transmission line causes a grid parameter over voltage and under voltage. So we have to take the operations in IHV lines. We are shutting down the line in the evening, we taken to service in the morning. So that is also impacting the even elements also. Then remain unutilization of the transmission network because solar has a 20% CUF. So almost rest out of 8 hours, 16 hours line will be on underutilization. So this is another issues. Then huge quantum of reactive power. This is also a severe problem for us. This is a reactive power issues. We have particularly captured the data of a particular three station where agricultural load is dominant. You will find particular daytime when solar is maximum. At that point of time, voltage is minimum beyond limit of the grid code, sir. In between, there is a jump 190 to 200. During the recess time, there is 12 to 1. Voltage is recovered, and then after further it is go down below 190. So this is a scenario specifically particular our Saurashtra areas, 3 220 kV substation and 3 132 kV substation. Everywhere you will find voltage is beyond the limit of the grid code. This is a generation of solar vis-a-vis voltage potential 400 kV substation voltage as well as 220 kV substation voltage. So this is a really very good challenge for us actually. How to handle this is the subject of academia. They have to exercise in this particular matter and help in particular scenario. Just I have talked before this slide that our total generation, out of total generation, coal generation is 41%. So we have to run our shows within that 40%. We have to manage our up and down, we have to manage our ramp rate, everything. So generally we are planning to procure the power from the IX in a particular ramp site. So at least that will be help. Another way is to shift the load in the daytime. So almost we have matched our ramp of the load with the ramp of the solar. But sometimes where solar is not done, then we are landed into trouble at present. Because our coal generation is almost having completed 30 years life. They have almost 1 megawatt ramp rate. And at present they are running at 60 to 70%. They are till date not reach at 55%. So this is a challenge for the coal generation. 3% is from the nuclear and 9% gas generation. Those generators we are operating daily basis in the morning peak and on a evening peak. So we have a capacity of around 1600 megawatt as in base, and it's a costly affair. More than 16 rupees we have to pay particular for this gas. But there is again issue of the gas availability. If gas availability is not there, then it will be costly more than 20 rupees. So these are the costly effect we have to take the action to balance the system. These are the major challenges of forecasting, sir. If we have proper forecasting, in absence of the proper forecasting, suboptimal operation of the conventional plant, then frequent start, stop and ramp rate, then system parameters like loading and voltage fluctuation will also impact. Our DSM penalty will also be impacted due to poor forecast. Same situation happened with the DISCOM. They have to overrule the merit orders. They have violated the limit of the DSM. So there is a need of having a better forecast that I think academia can help in this particular matter. We have an MOU with the at present IIT Gandhinagar. They are doing the work on that item. So we will find there are AIML based solution, and within 3 years of time we have an agreement of 3 years. So they will support in particular this item. In the state of Gujarat, we have a forecasting and scheduling regulation for RE since 2019, and you will see even after lapse of 5 years, there is no improvement in particular day-ahead forecast vis-a-vis real-time forecast and actual. There is a huge gap in forecasting error. You will find that in a day-ahead forecast, there is 3000 megawatt error. Even in a real time, which you can say they are revising their schedule every 1.5 hours. Even then, there is a gap of plus or minus 500 megawatts. So we cannot rely. This is the output of REMC's system. So even REMC is not going to help. We do have our indigenous system, and based on that we are taking the decision and operating the system for wind and solar, which is far, far better than this particular system. In case of solar, same scenario happened. In case of 15th March, you will see what was the forecast on day ahead, now what is the actual. So no way forecasting is helping us. Even REMC is also not helping us in the particular system. And in particular, this system I will try to have last graph. We have mentioned the week ahead. As per the regulation, there is a provision of week ahead forecast. So there is no sense in particular week ahead forecast, because it is not nearer about particular even trend. This is a solar and both. Even in that particular combining the wind and solar, even though in that particular day ahead forecast, there is a huge error in particular system. And one psychology, just sir has said, they have a margin of 7% and 12%. So they are considering that margin. Suppose I have a total RE installed capacity of around 20 gigawatt. So simply they assume that 7% band is mine. So 7% into 20 gigawatt. 1400 megawatt they have taken liberty. They don't care. We see that at present generation from wind is available only 100 megawatt. They are forecasting for 900 megawatt. So error is simply 600, 700, 800. We are issuing the notice them, please revise your schedule and be realistic, but nobody take care. So these are the issue at present we are facing from the RE sites. So this is the final, I have seen the day ahead, real time, what are the gap between actual and forecasting. So these are the actual power scenario, those we have just kept particular selection of the day, maximum day demand 504, at that point of what was the contribution and from where that was the contribution and how much was the solar and wind generation contribution. These are 5 scenarios, I left it for you. We have a trouble at the time of minimum demand, particularly in the month of July. You will find there is a huge gap of DSM, plus or minus 1000 megawatt DSM is there, because at that point of time my normal demand is around 400 million units, which was touched to 269 million units. Normally my demand is 22,000 megawatt on a daily basis, which was around 12,000 megawatt. So on that particular days, due to high wind scenario, wind generation show that it was more than even our actual demand scenario. So on that particular day, we are having a plus or minus on the both side. We are overdrawing by 1000 and we are also same way underdrawing by the 1000 megawatt. This is the real impact in particular July and August month when agriculture demand is not there. This is another one again scenario where we have to curtail the solar and wind both. In this scenario also I have to curtail the wind and solar. This is the unique way. Just before the start of this new year, our state government has already declared we have achieved 96% agriculture demand shifted into the day. And that way, because we have started in 21-22, and at present, in last year I have just compared two agriculture demand scenario in 2023 and 2024. There is a 2000 megawatt shift from the daytime to night time. At present, my demand is around 400 megawatt in particular night hours, and in daytime it will around 9000 megawatt. So this is the good idea to integrate the maximum solar during day, because my solar generation is at present maximum 6000, and within before March end it will touch around 7 to 8000 megawatt. Yeah, so this we are expecting 1500 megawatt more will be added into the system in a large scale. Same way 500 megawatt plus will be added into the distributed solar. So we will definitely touch whatever agriculture will be supplied to the solar. So this will be help when cloud is not there. If cloud is there, then we will be in trouble. So these are the challenges. What are the challenges after shifting the agriculture load in daytime? Just sir, he said that we are losing our flexibility. Previously, when agriculture demand was in a night time, we have a flexibility to shift the load during plus or minus 15-minute hours, whatever time is required. But now, we do not have any flexibility during night time. So we have to assure the power during the night time. So these are the actual challenges after changing the agriculture demand into daytimes. Then these are the issues for academia. If we are changing the solar at distributed level, will it be possible that we are supplying the farm plus solar? Should we install the distributed solar as well as battery? There is a requirement of distributed level solar, distributed level energy storage, because this will help during the monsoon when agriculture demand is not there. Certain, we have also find out, because still we have a 45 numbers of substations pending to convert into the daytime, where we are exploring the possibility. If possibility of small scale batteries is there, then we will absorb that generation, excess generation into the battery, and will connect the solar. So these are all the possibilities. But good way at present is, at present our transmission losses is reduced by 0.7% due to the large numbers, small scale generation is connected at the distribution level. They do not require to travel the power all the way from the transmission system. Another good issue, one solution was, it will avoid the cost of transmission at present immediately. So these are the two plus point you can say if you want to say something good about the distributed solar. These are the future roadmap. So pilot project for RE forecasting and scheduling, we have a MOU with IIT Gandhinagar, which is a project of 3 years. So after 3 years, we have an AIML solution for forecasting of wind, solar, and power portfolio management also. Then we are exploring the possibility of small scale. We have already started to explore the possibility of land availability nearby our substation to have a small scale even storage system with distributed renewable. One more solution which was I was thinking on this, two-part tariff for RE. It is a need of time because earlier at present when we are curtailing the renewable, they are loaded the cost, every cost into particular the tariff. If we give some two kind of thing that we will surely receive this kind of amount as a fixed cost, then this will resolve the little bit issues. So this one of the idea is that there should be a two-part tariff for RE also. Then because it will help in the supplying the reactive power also. So this kind of thing will be required to be thing. Then conversion of the conventional generation in a flexible two operations. We have to think that conventional generator should be operated into two shifts to absorb this kind of system. Then another way we are just thought that REMC should be merged into the existing energy accounting and scheduling software, because there is no need of two separate operators going to operate. So this is another way of, and we have already developed the portal for RE generation integrations, approvals, then first time chargings. Then we are upgrading our existing SCADA, which will include the RE generation, because recently in 31st August, Commission has given an order that every turbine should be have an RTU, which provides the data of wind parameters and energy parameter. This is the order which is already challenged by Wind Energy Association in Aptel and review file in a particular commission, but still Commission has not given any directive, so this order is still there. Then implementation of ADMS, Automatic Demand Management Scheme. Then implementation of SCD, which is under mock trial. Then Security Operations Center, which is already we have proposed and pending with the PSDF. Then implementation of ISO 27001 for cyber security. It is a serious matter. As far as RTU, we are giving the OT access to the outside the person. So anybody can enter into the My System through that OT network. So this is also an important item. And then implementation of the automatic meter reading to have a analytics and all these things for study purpose. Thanks for listening me here patiently. Thank you.
Me opportunity to represent Rajasthan. Well, Rajasthan, you know, is rich in renewable and a very peculiar type of renewable. Next slide. So, this is the complex EHV grid of Rajasthan. You can see the western part, which has recently developed, is because of the renewable. So this is the system we are now developing for mostly for renewable. You can see the consumption pattern and the losses. Of course, we had a time when losses increased. See, this is the generation pattern. You can see the renewable the blue one is the renewable. These are different sources from which Rajasthan gets power. Primarily coal, yes, but renewable is also substantial. So this is in terms of energy. Yeah, this is something which I want to stress. See, the thermal generation is centered in southern part or in the northern part. Of course, we have some lignite-based power plants in the western region, but we don't have gas power plants. The only gas power plant is in Dholpur area, which is very stressed because of the gas pricing. We don't have hydro. Rajasthan means, no water, so we don't have hydro. Only hydro is runoff river in southern parts. This is state central sector generation in the state, primarily nuclear, but Rajasthan has very little share, only RAPP-A. Of course, RAPP-D is also under planning. So, and we have a lignite thermal power plant, Barsing, sir, a small power plant, just 250 megawatt. Well, this is the story. We have very huge solar potential, 284 gigawatt wind and 142 gigawatt solar. The solar potential is very good because we have more sunny days, around more than 300 sunny days. So not a problem of cloud cover like thing, but of course the thing is that all this potential is located in western part, far off part. So this is where the solar is primarily located, the western region, and wind is in, of course, western side and some southern side also. So I will not go into detail each district wise. So these are the, where the wind and solar are located. This is the transmission system for wind and solar, developed specially for evacuation of wind and solar. Very huge system. I'll just run through because, see, so in these districts, we have developed a huge transmission system for evacuation of solar. So this is something you are more interested in. This is how the variable nature of wind power, and this is how intermittent solar is. This is the CUF of yes, of course, it is here. So CUF is 16% for wind and 21% for solar. So Rajasthan's load curve is typically different. We have huge agriculture load. So that load we have shifted to daytime, and we can cater it through solar power. Well, this is something we see at the SLDC. This is picture at night time, so solar is 0. We have some wind, 746 megawatt. And this is a picture in daytime when we have around 4,000 solar. So the problem with solar in Rajasthan is that most of the solar is located in the western part, which is far away from the load center and is evacuated through 400 kV and 132 kV lines, unlike other states where solar power is distributed throughout the state. In Rajasthan, wind and solar are generally complementary, so we find wind generation coming in night hours. We just saw that, and solar is high in the day hours. The problem which we are facing is that if wind generation exceeds a limit with the peaking solar, we have very peculiar phenomena of low voltage because of very low MVRs in the system, and voltages are ranging 370 to 380 kV at 400 kV GSS. We feel voltage fluctuations, and then we curtail wind. So these are the wind curves. Continuous days, you can see wind is definitely unpredictable. Solar, yes, typical solar curve. So with the Rajasthan, the thing is that having clear sunny days for most of the days in a year, we don't have such type of problem. Particularly in western Rajasthan, we have more than 300 sunny days. So our problem of cloud covers is, yes, it is there, but not as aggressive as for other states. Yes, we have the problem of high voltage and low voltage, and we need to switch on and switch off reactors and capacitors, losing the, damaging the circuit breakers. These are the issues which definitely we have. Continuously changing tap position of transformers and switching on and switching off shunt capacitors. So during the low voltage and high voltage time, in the night when the RE is low, we need to, lines are unloaded and injecting MVRs. And in the daytime when renewable is very high and not supporting MVR to the grid, then the low voltage phenomena is occurring. This is a case study. Recently we had in Rajasthan the phenomena of voltage oscillations. You can say voltage fluctuations. So this we think is because of the very bulky STATCOMs installed in ISTS network, which is connected to Rajasthan's intrastate network. We observed voltage fluctuations on 28th December this year, last year. These are the STATCOMs which are connected in ISTS network, very high capacity STATCOMs, 150 MVR STATCOMs in these substations with the shunt capacitors. So you can see at Power Grids Bhadla PG2 and Bhadla 2nd, there are these STATCOMs which are connected to RVPN's Bhadla substation. So the operation of these STATCOMs resulted in very huge voltage fluctuations in Rajasthan. Another STATCOMs at Fatehgarh, they are connected to RVPN's Jaisalmer 2 substation. So we found that irrespective of Rajasthan's demand was low, and the reactive power within the Rajasthan was not changing, and even the voltages were steady state. Suddenly, solar injection in ISTS network changed, and then Rajasthan observed these oscillations. We are continuously in touch with the RLDC, and they are doing a study, detailed study in this regard. Well, what we have seen that operation of these STATCOMs was very sluggish, and this caused this issue. We need to see that these are operated properly. See, when voltage was around 401, then suddenly it fall to 385, and then again rose to 400, and then rose to 412. So this is the 400 kV bus voltage at Bhadla, and this is the 220 kV bus voltage at Bhadla. These are the voltages at other grid substations in Rajasthan that were affected. So these are the issues, the voltage issues which we are facing. So these are the solutions, the possible solutions, that these STATCOM modes, change modes should be controlled, and even the switch shunt capacitors and reactors, they should be switched very carefully. Another issue which we are facing is the compliance of CA regulations regarding RE projects. So this is the regulation, this is what regulation says, that you need to inject RE as per the requirement, but the things are quite different. This is how the solar power plant should inject. We have given dispatch instructions for MVR, but that were not followed. So we conducted a survey. We monitored these substations and the lines where RE is connected, bulk RE is connected. So the compliance was not up to the mark. See, against the 45 MVR, which was to be injected at POI, the injection was hardly 3 MVR, 9 MVR, and sometimes they were drawing 2 MVR, 2.57. So these are the results for different RE feeders. So we recently called them and directed to comply, but the compliance level is not up to the mark. These are the challenges to the current challenges. Of course, we talked about the other challenges also, but having a bulk RE connected, these are the issues which we are facing. See, the generators do not have PPC and PQ meters installed. This is the major issue. The yellow one are the non-compliances. I mean, they don't have even PPC or PQ meters. Even the PQ meters are not properly installed. I mean, they should be at the POI, but they are at the pooling stations. So, and even the real-time data is also not coming to the SLDC. We just had this issue flagged. So, you can see against the total 200 generators, only 109 are reporting. Well, on 7th and 8th December, there were huge oscillations in the voltage. So, at that time we had to curtail the wind power. So, this is how we are doing right now. We are, directing the generators to follow the CA regulations and install PPC and PQ meters so that we can have visibility and we can, control MVR flow and directing them to adhere to LVRT, HVRT compliance. Yes, of course, SLDC and STU have to do these things also. We need to create the infrastructure. We have talked about ADMS and shunt capacitors, all these things. That's all.